Hi friends, welcome back to my YouTube channel Classroom Mania. This is the fifth part of the chapter Motion. If you haven't gone through the previous parts, the links are available in the description box. Go and check it out. So let's start today's class. Suppose a train starts from station A and its destination is station B. So when the train starts from station A, initially the velocity of the train is 0. After some time, it acquires some velocity and it becomes fast. Then again after some time, when station B approaches, the train becomes slow. And when it arrives station B, again it comes to rest, that means velocity becomes 0. So here you can see there is a change in velocity. First it was 0, then it was fast, that means velocity is more, then it becomes slow, velocity is less, then again it becomes 0. So here is a change in velocity continuously. So this change in velocity is termed as acceleration. So what is acceleration? The rate of change of velocity is known as acceleration, or we can say the change in velocity per unit time is known as acceleration. So now let's write the definition of acceleration. So what is acceleration? It is the rate of change of velocity or you can say change in velocity per unit time. Acceleration is denoted by the symbol small a. So now we will find the formula for acceleration. So acceleration is equals to change in velocity by time. This implies acceleration is a. So a is equals to change in velocity, means final velocity minus initial velocity by time. So this is the formula for acceleration, and SI unit is meter per second square, CGS unit is centimeter per second square. Now we will see two important cases related to acceleration. So formula for acceleration is A is equals to V minus U by T. First case is V is equals to U. What if initial velocity and final velocity are equal? Then what will happen to acceleration? Acceleration will be 0. How? We will see it now. So we will write the formula again. A is equals to V minus U by T. This implies AT is equals to V minus U. This implies AT is equals to V minus V, because both are same. This implies AT is equals to 0. This implies A is equals to 0. So acceleration becomes 0 when both initial velocity and final velocity are same. Now the second case is, what if initial velocity is greater than final velocity, that is U greater than V. Let's take an example to understand this. Suppose I take U is equals to 40 meter per second, V is equals to 20 meter per second, and T is equals to, let's take 2 seconds. Now we will find the acceleration here. So acceleration is equals to V minus U by T. This implies A is equals to 20 minus 40 by 2 meter per second square. This implies A is equals to minus 20 by 2 meter per second square. This implies A is equals to minus 10 meter per second square. So the answer is in negative. From this we got, when initial velocity is greater than final velocity, the acceleration will become negative. The answer will come in minus. So this negative acceleration is termed as retardation. So what is retardation? Negative acceleration is known as retardation. So now we will write it here. What will happen if u is greater than v? When u is greater than v, then a will become negative. So these are two cases related to acceleration. Now we will see what is uniform acceleration and what is non-uniform acceleration. Now, what is uniform acceleration? Equal change of velocity in equal interval of time is known as uniform acceleration. And what is non-uniform acceleration? Equal change of velocity in unequal interval of time or unequal change of velocity in equal interval of time. So now let's write that. What is uniform acceleration? Equal change of velocity in equal interval of time. And what is non-uniform velocity? Non-uniform acceleration. Equal change of velocity in unequal interval of time or unequal change of velocity in equal interval of time. Now let's do some word problems related to acceleration. So let's write our first question. So our first question is, find initial velocity of a car if it can be stopped by applying brakes in 10 seconds, which provide retardation of 2.5 meter per second square. So now let's see what is given in our question. So in our question the time is given. So t is equals to 10 second. Retardation is given, that is negative acceleration. So a is equals to minus 2.5 meter per second square. V is also given, that is 0. How V is given? It is said to be stopped. At the end the car is going to stop, so V is equals to 0 and we have to find U. So now the formula is A is equals to V minus U by T. This implies minus 2.5 meter per second square is equals to 0 minus U by 10. This implies minus 2.5 meter per second square is equals to minus U by 10. This implies minus 25 meter per second square is equals to minus U. Minus minus cancels. This implies U is equals to 25 meter per second square. So this is our initial velocity. Now let's take another example. Suppose a car is moving with a velocity of 72 km per hour and brake is applied to stop it. Which produces a retardation of 10 meter per second square. Find time taken. Now let's see what is given in the question and what we have to find out. So in the question it is given first the initial velocity. So u is equals to 72 kilometer per hour. Then it is given brake is applied to stop it. Stop means v is equals to 0. Then it is given retardation, that means negative acceleration. So a is equals to minus 10 meter per second square. Now we have to find the time. So time is asked here. If you can notice a thing, u is given in kilometer per hour and a is given in meter per second. So both the units are different. Now either we have to convert this meter per second square into kilometer per hour or this kilometer per hour into meter per second to find the right answer. Here we are going to convert this kilometer per hour into meter per second. So we will convert it here. 72 kilometer per hour, which is equal to 72 into 5 by 18 meter per second. Why we are using 5 by 18? That is already discussed in the previous class. So the result is 420 meter per second. So our u is 20 meter per second. So u is equals to 20 meter per second. Now we will calculate what is asked in our question. So the formula is a is equals to v minus u by t. Here we have to find the t, so we will take it here. This implies t is equals to v minus u by a. We will put the values here now. V is 0 minus 20 by a is given minus 10. So this is minus 20 by 10, that is 2. So this implies t is equals to 2 seconds. In this way, we can solve the questions related to acceleration. So let's end our today's class here. We will meet in the next class with the same chapter, motion, and a new topic, that is graphical representation of motion.